Evan, what are you doing?
Say a piece of the game.
You're in every one. All right, so here we go. Yesterday on our practice quiz, we're ready for 2E. All right, so 2E says find the determinant. We learned how to do that yesterday. Find the determinant of matrix A. Now you will notice that Mrs. Ford is not writing it down. What are the dimensions of matrix A? And to find the determinant, the matrix must be squared. So, not doable, not possible, no answer for 2E. To find a determinant, the matrix must be squared. Did everybody hear me say that? 2 days in a row, okay. Now F, can I find the determinant of matrix B? Yes, because it is squared. So who remembers how we do this? Take these two columns and write them right here. So 1, 2, 3, 1, 0, negative 1. They have to be written in that order, right? All right, so here we go. What do I do now once I get those written down? I start right here, always start right there, and multiply. What do I get? 0. Remember, times 0 is 0 every time. I multiply here. 3. 1 times 1 times 3. And then multiply here. 2. Now total all goes up. That's the grand total of this diagonal. Okay, now we're going to go the other way. So what's this one? 0. What's this one? Negative 1. And this one is 10. Now total those up. Now what do you do with those two numbers? Subtract 5 minus 9. So the answer to the problem is negative 4. All right, what does G mean? Find the inverse. Okay, so matrix C is 1, negative 1, negative 5, 3. This is a two-step process, remember? What do I do first? Find the determinant. He said cross multiply, that's find the determinant. So the determinant will be 3 minus 5. 3. If I times these, I get 3. If I times those, I get 5. It's a subtraction. So the determinant is negative 2. Then what do? I make a new matrix. And how do I make it? I take these two numbers and flip them, so 3 and 1. And then that's a negative, so it becomes a positive. That's a negative, so it becomes a positive. And to get my answer, I'm going to take each one of these, 3 and 1 and 5 and 1, and divide them by negative 2. If anything reduces, which often it does, you have to reduce it. Nothing simplifies in this, would you agree? Pay attention. This is the quiz that you're going to take the next time we're here. Okay. All right, other side. I got these matrices, looks like the same one. And I'm going to multiply B times A. Now there are a lot of numbers there, so before I write it all out, can I do it? what are the dimensions of B? B,
3 by 3.
3 by 3. What are the dimensions of A? Okay, good thing I didn't write it out because it's not doable. Order matters. It says B times A. That's not possible. Got it?
What do we write down, like, to just, like,
Can't
it
do.
doesn't, okay.
Impossible. No answer.
With no solution.
No solution. All right, what about 2A? Can I take 2 times A? Heck yeah, you can take 2 times anything. So what will 2 times A be? Negative 2, 2, 10, 6, 0, 4. Scalar multiplication is like the distributive property. There is nothing easier. Don't miss that. Now, what about 2A minus C? Can I take 2A minus C? No. What are the dimensions of A? 2 by 3. What are the dimensions of C? 2 by 2. How do I add and subtract? Same size, same dimensions. Again, no answer. This is going to happen on your quiz, guys. You're going to get problems that have no solution. Don't try to make something happen. There are rules, and if it doesn't follow the rules, then you know what? There's no answer. All right, what about the determinant of C? Is that a doable problem? I think I already, or maybe I didn't do this. No, I haven't done this yet. What's the determinant of C going to be? Oh, I did do this. 3 minus 5, negative 2, 3, 5, subtract. And finally, A inverse. Why can't I do it? A inverse isn't possible because what's step 1? Find the determinant. Is A square? Can you find a determinant? Can't find an inverse. No determinant, no inverse. Gotta be square. Got it?
What square do you mean? Like,
2 by 2.
They say like
3
this.
by 3. Same number of rows as columns. Alright, so this is going to be our quiz. So I would suggest that between now and whenever, God knows I see you again, you are going to maybe recopy them or try it again or something. Right? To make sure you know the rules. Okay, now I need you to get your notes out. And I did a wonderful job of running all images and numbering them in the wrong order. I'm not sure what the next going on. But I want you to find a page of your notes. It should be the next one. And up at the top it says use Cramer's rule to solve. Okay? We're finding the page in the notes. It says use Cramer's rule to solve. I got the page numbers on the wrong side, but it's the back of page 47. Alright? It says use Cramer's rule to solve. So, we took a quiz yesterday, which is graded, and I will return to it, in which we took problems that look like this, and we used substitution or elimination to solve, right? So, again, in the real world, if you are walking down the sidewalk and you find this system, you are allowed to solve it any way you want. You can substitute, you can eliminate, you can use Cramer's rule, the inverse, there's lots of ways to do it. My job is to give you the tools, so I'm gonna show you how Cramer's rule works. After you've done a couple, you may discover you really like it, and we'll talk about why. All right, so here's how Cramer's rule works. First of all, this would not be a good equation for substitution. Why? To get a letter by itself, you're gonna have to divide, and when you divide, you're gonna get fractions. It also would be a little bit inconvenient for elimination, because in order to eliminate either one, you're gonna have to multiply them both by something. Okay, that's easy, we can do that. But let me show you how Cramer's rule works. Step one, find the determinant of the coefficients. So the coefficients are 2, 3, 3, -4. Coefficients. What is to x and y? It is extremely necessary that they are lined up. So these are the x's, these are the y's. Find that determinant. You know how to do that. What is that determinant? Well, what do I get here? -8. What do I get here? 9. What do I do with those two numbers? Subtract. So the determinant is -17. Now, I'm solving a system. The answer to the problem is going to be an ordered pair, right? X, y. That -17 is the denominator of both answers. So I'm gonna figure out what those numerators are, but whatever they are, they're over -17. Now, how do I find the numerators? Well, it's super simple. To find the x numerator, it's another determinant. But, if you're finding x, you take these out, the x numbers, take them out, and replace them with these. So take the 1 and the 2 and put them right here in the x spot. So you're gonna have 1, 2, and then you still have your 3, -4. So if you're solving for x, these numbers replace the x's. The equals numbers replace the x's. All right, what's that determinant? -4 -6. So -10, that's what goes right here, -10. Now, I know those cancel, I'll come back and cancel them later, but that's how I get my x. How do you think I get my y? Same thing, but now I'm gonna cut these out and paste them here. Now, look what that looks like. 1, 2, right here. So I have 2, 3, and then 1, 2. You gotta get them in the right spot. These are gonna cover up whatever letter you are solving for. Okay, what's the value of that one?
0.
No,
1.
4 minus 3. 2 times 2 is 4, 3 times 1 is 3, 1. So the answer to the system, the negatives cancel, so it's 10/17, comma -1/17. Now, I want to talk about why there are people who really love Cramer's rule. I told you, I'm an eliminator, I'm gonna eliminate every time. When I eliminate, depending on what I eliminate, let's say I eliminate the y's, I would get 10/17 for my x value. And then what would I have to do with that 10/17? Oh, yuck, yuck. Plug it back in. If you do Cramer's rule, you can get hideous answers, but do you ever have to work with them? No. So if you do Cramer's rule, it doesn't matter whether I rig the problem or not, you can get answers like 17/67. It doesn't matter, because you never have to use that number. Alright, next. B, we're gonna do exactly the same thing. We're gonna solve using Cramer's rule. When we get around to a test, and it's a while yet, but when we get around to it, there'll be a page of your test that says, solve the system. And then it will say, using substitution, using elimination, using Cramer's rule. Okay, so like the quiz you took yesterday, you had 2 of those, now you have a 3rd way that you're gonna solve. So, here we go, Cramer's rule. What is step 1?
Put in a matrix.
Find the determinant of the x and y numbers. So what do we got? 1, 1, 2, -1. And I like to label them x and y, you certainly don't have to, but they have to be lined up. So make sure your x's and y's are lined up. All right, what's the value of that determinant? I heard somebody say -3, and whoever said that was right, because it's -1 and 2, and I'm subtracting, so it's -3. What do I do with the -3? It is the denominator of my answer. Remember, your answer is an ordered pair, x comma y. Both of them are over -3. All right, now we're gonna find the numerators. Okay, so what's my x numerator? Take the 7, 8 and put it right here. So this is now 7, 8. 1, -1. Please take a moment and make sure you got that, because sometimes kids, students, young men and women will put the 7, 8 in the wrong spot. It has to go right here, 7, 8 in the x spot. All right, what's that value? -7 minus 8, -15. So your x numerator is -15. Okay, that's gonna simplify, but I'll do it in a minute. Now, what about my y? The 7, 8 goes here. So the 1, 2 stays right where it's at. So I have 1, 2, and then 7, 8. Minus 14, -6. Now, just like always, clean it up. What's -15 over -3? 5. And what's -6 over -3? 2. So that one came out nicely. If I substituted or eliminated, it would come out nicely. Okay, we getting a handle? All right. You see on your own with your partner. See if you and your partner can figure out what's going on with problem C. I'll do it up here, but don't look up here. Get it figured out as best you can. set your denominator, your coefficient determinant to be 10? Okay, that's good. Okay, where are we? Are we all on board here? This is what I got as my final answer. Lucas is back there, thumbs up, Tyron's nodding. So we're all good? Okay, there's one more. Do I have somebody who is willing to come up and do it on the board instead of doing it at your seat? Do I have a volunteer to do the last problem? Here comes my man Jose. You don't need a calculator, Jose. Be brave. Be brave. You got it. Right, everybody else should be doing it so we can check Jose's work. You know, when you think about it, aren't you just amazed at how smart some of these guys were? Gabriel Cramer, how smart he was to figure this out. They were smart people.
The dinosaurs were so long.
Is that 1800s?
I made them.
Really, you did make numbers. If you think about it,
Who made 0, 1, 2, 3, 4, 5, 6?
how do you
But
make,
yes, this plus this is this.
how do you explain to somebody what 0 is?
Nothing. It's just
But nothing is something.
Gabriel Cramer.
That's, my mom
true.
loves that.
Right.
She says we
He was a brilliant mathematician.
man, she not know that's fine.
It's probably my team.
Ask her something.
Look,
I don't
don't
know.
flip it, bro.
Okay, so this is gonna be, step aside, I'm glad you did this, we were gonna fix it, but I'm glad you did. This is gonna be a mistake that's made. We need to make sure that when we are evaluating determinants, the first multiplication we do starts right here. Always. So this has to be 16 minus -3. Yep. Do it, fix it. He did the top one right. He got -55 23rds and 19 23rds. Is that what you got?
Yes.
So again, think about if you had done that with elimination or substitution, what a mess. What a mess that substitution back in would be, plugging in your X. This is so much handier. There is one problem with it though. What would have happened if, when Jose did his coefficients, what would happen if that came out to be 0?
No solution.
We're in trouble because what do we do with that number? It goes into the denominator and the denominator can't be 0. Now, when that happens in Cramer's rule, and this is a drawback of Cramer's rule, and I'm not gonna do this to you, but just for your own information. When that happens in Cramer's rule, you don't know whether it was no solution or infinitely many. All you know is that something's wacko, right? So then you have to go back, if you wanna know, is it the same equation or are they parallel lines? You have to go back and use another method to figure that out, because Cramer's rule won't tell you that. Okay? All right. Good. All right, now we're going back to our notes. So now we're going to 7.3, where it says use a calculator to solve. Okay, so everybody's got a calculator out. Everybody's gonna follow directions. You guys that love to work ahead and do other stuff, please don't, because I'm going to get very frustrated if I have to keep repeating this. So we're gonna all stay on task here. All right. Step 1, we're gonna do problem number 1. Use your calculator to solve the following. First thing that I want you to do is make a big giant matrix full of every number in the problem. So, 1, 1, -1, 2. See what I'm doing? That's the top equation. And then 2, -1, 3, 14. And then 3, 1, 1, 14. The problems that we just did had X's and Y's, and our answer came out to be X and Y. These have X, Y's, and Z's, so your answer is going to come out to be an X, a Y, and a Z. That's called an ordered pair. This is called an ordered triple. Okay? Geometrically, what's happening, the ones that Jose just did, that was 2 lines and a crossing at that point that he found. What we have here are 3 planes. So this is like the ceiling, this is like the front board, and this is like that side wall. Well, where are all those planes coming together? They're coming together in that corner right up there. We are looking for the corner point where these 3 planes come together. It can be done by hand, but it's so much easier with the calculator. So we're gonna do it on the calculator. All right. We're gonna put that matrix into our calculator. So let's turn it on. Right here where I am pointing in the first column, 4th button down, you should see the word matrix written in blue. I think mine's blue. Yours blue?
Yeah.
Okay, when it's blue, you're gonna use your second button to get there. So press second matrix. And then it pulls up a menu across the top that says names, math, and edit, right? When you are getting ready to put a matrix into your calculator, you do it in edit mode. So click over till edit is highlighted. Okay, edit highlighted. And matrix A is highlighted probably. Press enter. Okay. The first thing it asks you for, you should see a flasher up here in the corner. It wants to know, okay, you're gonna put a matrix in, how big is it? You have to tell it, how many blanks do I need to fill? Well, what are the dimensions of this matrix? 3 by 4. So you type 3, enter, 4, enter. And then it pops you down into the matrix and you're gonna put in the numbers. So you put in 1 and press enter. Now pay attention to where the cursor is now. It's going sideways. So then you put in 1 and enter, and -1 and enter, and 2 and enter. Then what does it do? It goes down to the next row. So we'll put in 2, -1, and remember, when you're putting in negatives, guys, you gotta be using your negative button. Don't use the subtraction, you're gonna get an error message. Gotta use the negative button. So 2, -1, 3, and 14. And then it's gonna pop you down here, 3, 1, 1, 14. Why are you not typing? Good, you got it in already. After you press this last 14 and hit enter, I want you to second quit. Quit's in the very top, right next to the second button is the quit button. Second quit. So what we just did was put our matrix in. Now, it's in there forever. Till you take it out or change it, it's in there, so you don't need to worry about it, it's safe. Now, what are we gonna do to it? Well, we're gonna allow our calculator to transform that matrix into a new matrix. And we're going to make that happen using our RREF button, which stands for, in case you're interested, Reduced Row Echelon Form. You are going to change your matrix into Reduced Row Echelon Form. So here's how that works. Go back into your matrix menu. So remember that second matrix. Now, a minute ago, I went over to edit. Why did I go over to edit? Because that's how I put the numbers in, right? They're in there already. Now I want to do something with them, so I'm going over to math. I'm going to do matrix math. You have a whole bunch of things there in the list. Just arrow down until you come to the one that says RREF. You need 2 R's, RREF. You find it? Press enter. Now, the calculator's asking you, okay, I'm gonna RREF what? Well, we wanted to RREF the matrix A that we just put in. So second matrix, enter. Now it should say RREFA. Press enter one more time. And it produces a new matrix that looks like
Yours
this.
is wrong.
So raise your hand if that's what you got. One person in the room got that? Okay, okay, good.
Okay.
Now, if you got something different, then you typed in a number wrong. So go back to matrix A, second matrix edit, and put your numbers back in. Now, we're gonna do this again. I need everybody paying attention now. We're not gonna do this problem again. We'll do the next one again. Here's the deal. When you put the matrix in, look at the original problem on the paper. Weren't these the X's? And these were the Y's, and these were the Z's, and these were the equals numbers? Right? Now, when you transform the matrix, everything stays the same. So this is your X's, Y's, Z's, and equals. So what does the top row say? X plus nothing else, no Y's, no Z's, equals 4. So X is 4. Y is 0. And Z is 2. There's your answer, 402.
I learn something every day.
Yep, you sure do, especially when you come to math class. All right, so let's try the next one. So, this is for what am I responsible for writing down? Because basically you did nothing except press some buttons. You must write down what I have written down. So, for number 2, we're going to start with the matrix that's going into our calculator. Write it down. 1, 4, -2, 0, 2, 1, 1, 6, -3, 3, -5, -13. Alright, so everybody gets those numbers written down. You will mess up if you don't have the right numbers in the calculator, so take your time, get them written down. Okay, now we're gonna put that in. So we're gonna hit second matrix. We're gonna go over to edit. How big is this one? Same size as before, right? So it's 3 by 4. So you can either retype it or just click over. And now you're gonna put these numbers in. You're just gonna put them in right on top of the other ones, guys. Don't worry about it. Put them right in on top of the other ones. So 1, 4, -2, 0. 2, 1, 6. -3, make sure you're putting in your negatives. Now, Owen's already ahead, so he remembers all the steps. For those of you that don't, once you get the -13 in, and you've pressed enter, then you're gonna do second quit. We need to get out of that menu. Okay, then we turn around and we go right back in. So second matrix, but this time we go over to math, and then all the way down to RREF, reduced echelon form. Press enter, and then tell the matrix, or tell the calculator, I want to do matrix A. So second matrix, enter, and that one turns out to be, if I didn't make a mistake on something, does that look like what you got, Owen? Yeah. Now, this is what you have to write down. You have to write down the original matrix that goes in. You have to tell me I pressed the RREF button, and this is the matrix that came out. That's all you have to write down, except for the answer. You gotta write the answer. So the answer to this problem is 3, -0.5, and +0.5. Okay, if you know what you're doing, stop writing and raise your hand. Okay, leave it up. Get it up high. Noah, get your hand up high. Okay, if you do not know what you're doing, then I want you right now to go find one of the people with their hands held high and do the next problem with your partner. So, number 3. So, go ahead and put your hands up. Does everybody know what you're doing? So if I gave a quiz right this minute, everybody would, okay, then get some help from somebody that had a hand up. Okay? So here we go. Go ahead and do problem number 3.
This is 4.
Yep.
If it doesn't have a Y, is it just 0?
Yes. If you are missing a letter in your equation, then you have to put a placeholder in, and that would be 0. So for equation in problem number 3, equation number 2 will be 2, 0, -3, -1. Remember, you're lining them up, X, Y, Z. It won't work if you don't line them up. If you are missing a letter in an equation, put in a 0 to hold that place.
Wait, let me see
You 1, 2, 1.
Yes, sir.
Now, I heard somebody say I did something wrong. If you didn't get 1, 2, 1, probably something happened here. That you either got your numbers mixed up or forgot a negative or something. Because the calculator ain't gonna make mistakes.
How do we delete the old matrices out?
I think there's a way, I'm not exactly sure. I never deleted them, I just put it on top of them.
Okay.
Don't worry about it. You type right on top of them, change your dimensions, you do whatever you want. Google how to delete them. All right, now, number 4. Be careful. Be careful with number 4. Number 4 has X's, Y's, Z's, and W's. Right? So what is that first equation gonna be? 1, 1, -1, 0, 4. What's the next one? 0, 1, 0, 1, -4. You getting the hang of this, folks? Next one. 1, -1, 0, 0, 1. And the last one, 1, 0, 1, 1, 1. When I get my answer, oh, by the way, what are the dimensions of this guy? 4 by 5, make sure you tell the calculator. My answers are gonna be X, Y, Z, W. And when they're not in alphabetical order, it's a good idea to write that up there. So everybody knows X is this, and W is this, and whatever. I type that in faster than usual, and I am not a good typist. Did anybody get these 4.5, 3.5, 4, and -7.5?
Yeah, I got it.
How come every time like there's ones are like going in the back?
That's the beauty of reduced row echelon form. That's what it does, because you wanna know, remember, this is X, Y, Z, and W. You wanna know what is X equal. So it wipes out Y, Z, and W, it leaves you with just X. And then the next row wipes out everything except Y. And then it wipes out, see, isn't that awesome? Isn't that awesome? Another great mathematician, this is called a process. If we did this by hand, so when I was your age, I had to do all this by hand. That process is called Gauss-Jordan reduction, kind of a combination of two great mathematicians. But yeah, I had to do that by hand. It took a little longer than it takes us. All right, we have one more to go. One more, number 5. Please watch it on number 5 because we have some zeros floating around in there again. All right, and I'm gonna do a quick calculator check. Okay, if you're gonna continue to use that calculator, you gotta know how to use it, okay? So you figure that out. Yep. And I haven't typed this in, but my guys up here in the front who have been all over this are expressing some concern. I did not type it in. Owen says that when he did it, this is what he got, 10.20, and then 01.80, and then 0001. Is that what someone else got? Can you confirm that? Okay, so this is bad news or good news, depending on which way you look at it. As I was just explaining to Evan, normally this is the way these things come out. They literally say 1x equals 1, 1y equals 2, and 1z equals 3. That's what they say. What is this bottom row? This is an equation. This is x, y, and z. What does that bottom row say? No x's, no y's, no z's, add up to 1. That doesn't make any sense. Can nothing add up to 1? No. What is the solution to this system? None. They don't intersect. They don't intersect. That is not uncommon at all. When you think about it, think of the front board, the side board, and the back board. Do all 3 of those intersect in a point somewhere? No. Not that one, that one, and that one. No, they don't. That's what we have going on here. We have 3 planes that don't intersect. Okay. No answer. Okay? All right. All right, so now we have good news and we have bad news. Okay? Good news is we seem to understand what we're doing. Bad news is now you have 2 homeworks due on Thursday. Because
No, the answer is no.
7-2 is due Thursday, and now 7-3 is also due Thursday. okay? 7-3 is one calculator problem and 2 Cramer rules. It's gonna take you about 10 minutes to do. Alright, so no warning. We're gonna have 7-2 and 7-3 due on Thursday. For
Alright, Gina, stop this.
Thursday. Those of you, I'm gonna stop before you